I am Radhakrishna, mathematics teacher. Today we are going to continue our topic parabola. We are going to solve problems. Already we have completed the theory in the previous class. And before starting the problems, I would like to remind you that all of you need to take the test. Don't miss tomorrow's test. Okay. Let us start the problems. The first question is, if three distinct normals can be drawn from h comma 0 to the parabola y square is equal to 4x, find the smallest integer h. Let us first draw the diagram. Let this be y square is equal to 4x, its axis is x axis, origin is vertex. Okay. H comma 0 is a point on axis. If three distinct normals can be drawn from h comma 0 to the parabola, here you can directly see that x axis is a normal passing through h comma 0, because at origin tangent is y axis and x axis perpendicular to the tangent at vertex, so it is normal. So directly one normal always exists for any value of h. Now another two normals should exist. So let us assume two more normals like this, one normal like this, another normal like this. By symmetry, if one normal exists that side, then definitely another normal should exist this side. So we are taking two normals. Now if two such normals exist other than x axis, then what is the condition on h? Let us take this point as p of t. Then t will have two values. Okay. Now t is equal to 0 represents the origin. So definitely in further process we are going to get t is equal to 0 also, and that is ignored. We should get two more distinct values of t. Okay. Now at p of t, what is the equation of the normal to the parabola? Tx plus y is equal to a t cube plus 2at. What is a in the parabola? A is 1. So t cube plus 2t, equation of the normal at p of t. Normal at p of t. Now if it passes through h comma 0, substitute h comma 0, you will get th is equal to t cube plus 2t. Then t cube plus 2t minus th is equal to 0. Taking t common, t into t square plus 2 minus h is equal to 0. You will get t is equal to 0 as a root. Already we have discussed about it. T is equal to 0 corresponds to vertex, which is origin. Now the other two roots are given by t square is equal to what? H minus 2. So t is equal to plus or minus root h minus 2. If you have two distinct values of t, then this must be real. If h minus 2 is positive, then you are going to get two distinct values of t. So what is the condition? H should be greater than 2 if these two values of t are real. If h is greater than 2, what do you want? Smallest integer h. Therefore h is equal to 3. The smallest integer h is 3. Okay. But in this question, it is better to remember a general point. If this parabola is y square is equal to 4ax, if you proceed the same calculation, you are going to get t is equal to plus or minus root h minus 2a. So, h should be greater than 2a. So, on the axis of the parabola, from the points on the right side of 2a comma 0 only, you can draw 3 distinct normals. From 2a comma 0 and points on left of 2a comma 0, x axis is the only one normal. The other two normals do not exist, is it not? So, remember this point carefully. 2a comma 0 onwards on the right of on the right of 2a comma 0, you are going to get 3 normals on the axis, on left only one normal. Okay. Let us proceed to next question. Find the locus of the point of intersection of perpendicular normals of the parabola y square is equal to 4ax. Let us consider the parabola like this and take two perpendicular normals from some point P. This is one normal and suppose this is perpendicular normal. We want the locus of this point, take it as x1 comma y1. Then let us take this point as A, this point as B. We know that if two normals exist, then definitely third normal also should exist, because if the cubic equation, in the previous question we got a cubic equation t cube and so on, if that equation has only one real root and two imaginary roots, then only one normal can be drawn. If it has three real roots, then three normals can be drawn. Out of the three real roots, two may be equal to each other, then total number of distinct normals will be 2. Okay. So, definitely third normal should exist, that may coincide with one of these two or that may be different. So, let us draw the third normal also like this. This foot is C. Now, out of the three normals, two are perpendicular to each other, then what is the locus of P? That is the question. Here what we do is, let us assume the normal in slope form. Why slope form, not parametric form? Because two normals are perpendicular to each other and we directly have a condition that if two lines are perpendicular to each other, product of the slopes is -1. That is why we are using slope form of the normal. Let a normal be, what is the slope form of the normal of this parabola? Y is equal to mx minus am cube minus 2am. If it passes through P x1 y1, we will get y1 is equal to mx1 minus am cube minus 2am, substituting x1 y1. Now, this becomes a cubic equation, am cube plus 2a minus x1 into m plus y1 is equal to 0. Now, this cubic equation will have three roots. Let us take the three roots as m1, m2, m3. Then m1, m2, m3 will be the slopes of these three normals. If the slopes of these three lines are m1, m2, m3, then m1, m2, m3 are the roots of this cubic equation. So, we know the relations between the roots, m1 plus m2 plus m3 is equal to 0, because m square term is absent, and m1, m2 plus m2 m3 plus m3 m1 is equal to 0. Sorry, not 0, 2a minus x1 by a. What is the third condition? Product of the roots m1, m2, m3. m1, m2, m3 product of the roots is minus y1 by a. Now, if two of the three normals are perpendicular to each other, what is the locus of P? Let us assume that first this normal and this normal are perpendicular to each other, then we have m1, m2 is equal to minus 1. If m1, m2 is equal to minus 1, then automatically these two are perpendicular to each other. Then in the third equation, if we substitute, we will directly get m3. m3 is equal to y1 by a. m3 is the root of this cubic equation now. So, directly we can substitute m3 in this equation and get the locus. So, no need of using these two conditions. Substituting m3 is equal to y1 by a in the cubic equation, you will get a into y1 cube by a cube plus 2a minus x1 into m is y1 by a plus y1 is equal to 0. You can cancel y1, remaining is y1 square by a square, a also cancels, plus 2a minus x1 by a plus 1 is equal to 0. Multiplying both sides by a square, we will get y1 square plus 2a square minus ax plus a square is equal to 0, which reduces to this x1. y1 square is equal to a into x1 minus 3a. Then replacing x1 by x and y1 by y, we get the locus of P. Therefore, locus of P is y square is equal to a into x minus 3a. So, this is our answer. The same question can be asked in a different form. If two of the three normals that can be drawn from a point P to the parabola y square is equal to 4ax are perpendicular to each other, find the locus of P. Same method, same procedure, same answer. Now, I am going to explain another method. This is method 1. In second method, again let us take the diagram. This is the parabola. I am going to draw two perpendicular normals. This is origin. Suppose tangents at 2 points A and B are perpendicular to each other, then the corresponding if the normals at A and B are perpendicular to each other, then tangents at A and B will also be perpendicular to each other. Okay. So, first let us draw tangents. Draw a tangent from A and draw a perpendicular tangent from B. This is B. tangents at A and B are perpendicular to each other, then automatically normals at A and B will be perpendicular to each other. Okay, their point of intersection is P. Let the point of intersection of the tangents at A and B be C. Okay. Now, let us proceed with parametric coordinates. Let points A and B be T1 and T2. Then what is the formula for point of intersection of the tangents? C will be A T1 T2 comma A into T1 plus T2. Okay. Let us suppose P is x1 y1. Now, if the tangents at A and B are perpendicular to each other, we have a condition T1 T2 is equal to minus 1. T1 T2 is equal to minus 1. The perpendicular tangents intersect on the directrix, and one more point is AB will be the chord of contact of C, or sorry, AB is the focal chord of the parabola. If you join A and B, it will be a focal chord. Okay. If the tangents at A and B are perpendicular to each other, then chord AB will be a focal chord, it passes through the focus. Condition is C1, T1, T2 is equal to minus 1. Now, you observe that this figure is a rectangle, ACBP is a rectangle. What is the property of rectangle? The diagonals bisect each other. Midpoint of CP is equal to midpoint of AB. What is the midpoint of CP? Midpoint of CP is A T1 T2 plus x1 by 2, but T1 T2 is minus 1. So, I will write this as minus A directly. Then midpoint of PC or CP is equal to midpoint of AB. Since it is a rectangle, midpoint of PC is x1 minus A by 2, comma y1 plus A into T1 plus T2 by 2. It is equal to midpoint of AB, sum of the x coordinates by 2, sum of the y coordinates by 2, that is A T1 square plus A T2 square by 2. We can write as A into T1 square plus T2 square by 2, comma y coordinates 2A T1 plus 2A T2 by 2 is A into T1 plus T2. Now, equating x coordinates, we get x1 minus A is equal to A into T1 square plus T2 square. Equating the y coordinates, we get y1 is equal to A into T1 plus T2. Cross multiply by 2 and calculate y1. Now, by eliminating T1 and T2 from these two, we have to get the direct relation between x1 and y1 using this condition. How to eliminate x1 and T1 and T2? Let us square this on both sides. Y1 square is equal to A square into T1 plus T2 whole square. T1 plus T2 whole square is T1 square plus T2 square plus 2 T1 T2. You can substitute T1 T2 as minus 1 and T1 square plus T2 square as x1 minus A by A. So, we will get A square into x1 minus A by A plus 2 T1 T2 is minus 2. then simplifying it, you will get y1 square is equal to a into x1 minus 3a. So, what is the locus of P? Replacing x1 by x and y1 by y, we get y square is equal to a into x minus 3a, which is the same answer as the first method. Next question. The normal set P and Q on a parabola y square is equal to 4ax intersect on the same curve. The tangents at P and Q intersect at R. Then find the locus of the circumcenter of the triangle PQR as P and Q vary. Let us take the parabola like this, write properly. Let this be the parabola. Tangents at 2 points P and Q, normals at P and Q intersect on the same curve. Both are normals, they meet on the same curve. Let us suppose P is T1, Q is T2. What condition did we discuss in the last class? If the normal set P and Q intersect on if the normal set P of T1 and Q of T2 intersect on the same parabola, we have discussed one condition. T1 T2 is equal to 2. We proved it also. Next, the tangents at P and Q intersect at R. Draw tangents. One tangent like this, another tangent like this. So, this is R. Okay. Then, if you draw circumcircle of this triangle PQR, what is the locus of the center of the circumcircle? That is the question. Now, it is better to take the diagram separately. The same diagram I am drawing. This is P, this is Q, this is R. Okay. Now, let us take this point as S. S lies on the parabola, no? So, let us take S is with parameter T3. Now, what are the coordinates of R? If P is T1, Q is T2, then point of intersection of the tangents at P and Q, A T1 T2, A into T1 T2 is 2, so I will directly write 2A, comma A into T1 plus T2. Okay. R is actually A T1 T2 comma A into T1 plus T2. T1 T2 is 2. So, this is 2A, and if you take point S, there are two normals passing through S. We can directly draw one normal at point S. At every point on the parabola, we can draw a direct normal. So, this is third normal passing through S. So, three normals are concurrent. Normal set which points are concurrent? Normal set points T1, T2, T3 are concurrent. If the normals T1, T2, normal set T1, T2, T3 are concurrent, what is the condition? T1 plus T2 plus T3 is 0. So, we can write y coordinate of R as minus A T3. So, I will write this y coordinate as minus A T3. And point S is a t3 square comma 2at3. Okay. Now, if you draw circumcircle of triangle PQR, you observe that this angle is pi by 2, this angle is pi by 2, because this is tangent, this is normal, and sum of the opposite angles is 180 degrees. If the sum of the opposite angles in a quadrilateral is 180 degrees, what can you tell? It is a cyclic quadrilateral. So, PRQS is a cyclic quadrilateral. That means circle passing through PQR passes through S also. Next, let us draw that circle. Circle is drawn through PQRS. One more thing is, since this angle is pi by 2, this angle is pi by 2, RS will be the diameter of the circle, because you know that angle in a semicircle is pi by 2. So, this angle is pi by 2 means this is a semicircle. Similarly, this is another semicircle. So, what will be the circumcenter of this circle, center of this circumcircle? Midpoint of RS. We want the locus of circumcenter. So, let us take circumcenter as x1 comma y1. Now, circumcenter x1 comma y1 is equal to midpoint of RS. Directly find the midpoint, at3 square plus 2a by 2 comma 2at3 minus at3 by 2 means at3 by 2. So, we got both x1 and y1 in terms of t3. Now, we get the relation between x1 and y1 by eliminating t3. How to eliminate? I will show in the next page. x1 is equal to at3 square plus 2a by 2 and y1 is equal to at3 by 2. How to eliminate t3? Cross multiply here, 2x1 is equal to a into t3 square. We can write t3 as 2y1 by a. So, t3 square is 2y1 by a whole square plus 2a. Then simplify, this is 4y1 square by a plus 2a, multiplying by both sides by a, 2ax1 is equal to 4y1 square plus 2a square. Now, replacing x1 by x and y1 by y, we get the locus. Therefore, locus of x1 y1 is 4y square minus 2ax plus 2a square is equal to 0. You can cancel 2 and write 2y square minus ax plus a square is equal to 0. This is the locus of the circumcenter of the triangle PQR. This model is very important. Now, let us proceed to next question. If a normal chord of the parabola y square is equal to 4ax, which is inclined at an angle theta with the axis, subtends a right angle at vertex, find the value of tan square theta. Take a parabola like this, draw a normal at some point. I am drawing at this point P. This normal is inclined at an angle theta with the axis. Axis means x axis. This is origin, axis is x axis. So this angle is theta, and this normal chord subtends a right angle at vertex. So if you join the endpoints of this normal chord to the vertex, this angle is pi by 2. This is the given information. Now we need the value of tan square theta. Okay. How to start this question? Usually parametric coordinates are always better. So I will take P parametrically as T1. Let the other end of the chord be Q of T2. If the normal at P meets the parabola again at T2, what is the condition? T2 is equal to minus T1 minus 2 by T1. Immediately write it. And if this is theta, slope of the normal is tan theta. What is the slope of the normal at P of T1? We have already discussed. The equation of the normal is Tx plus y is equal to ATQ plus 2AT. What is the slope? Minus T. Slope of the normal at P of T is minus T. So at this point slope of the normal is minus T1. So tan theta is equal to minus T1. Tan square theta means T1 square. So we need to find the value of T1 square. Now one more condition is not yet used. What is that? Angle between OP and OQ is pi by 2. If the angle between OP and OQ is pi by 2, product of their slopes is minus 1. What is the slope of OP? Slope of OP into slope of OQ should be minus 1. Slope of OP is, use slope formula, this is AT1 square 2AT1, this is origin. So 2AT1 by AT1 square is 2 by T1, slope of OP, into slope of OQ will be 2 by T2. This product is minus 1, then we get T1 into T2 is equal to minus 4. Using that condition and this condition, we have to find T1 square. So how to proceed? Here T1, T2 you have, and T2 is equal to minus T1 minus 2 by T1. So what to do? Multiply both sides by T1. You will get T1 T2 is equal to minus T1 square minus 2. This is minus 4 now. It is minus 4. Therefore, T1 square is equal to how much? Plus 2. Therefore, tan square theta is plus 2. So answer is 2. Next question. The normal at P of y square is equal to 4ax meets the axis at Q. The line through Q drawn perpendicular to PQ touches a fixed parabola. Then find the latus rectum, focus and directrix of this fixed parabola. Let us draw the diagram. This is the given parabola. Normal at P, draw a normal at P, meets the axis at Q. This is Q. Now a line is drawn through P perpendicular to PQ. A line is drawn through Q perpendicular to PQ, like this. Okay, PQ, this is perpendicular to PQ passing through Q. It is said that this line, say it is L, touches a fixed parabola. Then find the latus rectum, focus and directrix of that fixed parabola. Okay. Now let us start with parametric coordinates. I will take P as P of t. Then what is the equation of the normal at P of t? Equation of the normal at P of t is Tx plus y is equal to ATQ plus 2AT. Now what will you do? Solving with x axis means putting y is equal to 0. Putting y is equal to 0, you will get x is equal to Tx is equal to ATQ plus 2AT. Cancelling t, you will get x is equal to AT square plus 2A. Therefore, point Q is AT square plus 2A comma 0. Okay. Now we have to draw a line L perpendicular to PQ through Q. What is the slope of PQ? Slope of this normal minus t. So slope of L will be 1 by t. Okay. So what is the equation of L? Equation of L is, we have point and slope, how much? 1 by t. So y minus 0 is equal to, y is equal to 1 by t into x minus AT square minus 2A. All of you know point slope form. Now simplifying it, you will get x minus ty minus AT square minus 2A is equal to 0. We got a straight line L, but it is containing a parameter t. Here t is a parameter, t varies. When t varies, this line also varies. But first we have to prove that it always touches a fixed parabola, then get the equation of the parabola, then calculate its latus rectum, focus and directrix. How to show that this line always touches a fixed parabola for any value of t? Let us observe the standard forms and their tangents. Y square is equal to 4x is a standard parabola. What is the slope form of the tangent? Y is equal to mx plus c, mx plus a by m. This line always touches this parabola for any value of m. Similarly, if it is y minus k whole square is equal to 4a into x minus h, what is the slope form of the tangent? Y is equal to, slope form of the tangent is y minus k is equal to m into x minus h plus a by m. This is the slope form of the tangent of this parabola. What is the slope form of the tangent of the parabola x square is equal to 4ay? Y is equal to mx minus am square. What is the slope form of the tangent of x minus h whole square is equal to 4a into y minus k? You have to replace y by y minus k and x by x minus h in the above formula. We get y minus k is equal to m into x minus h minus am square. These are the standard forms we have. For a general parabola, we can't write the equation of the tangent in parametric form or slope form. Only for standard forms it is possible. Now, what is the equation we got? This equation, x minus ty minus at square minus 2a is equal to 0. I will write it here. X minus ty minus at square minus 2a. To show that it touches a fixed parabola, we must write that equation in one of these four forms. Let us first write ty is equal to x minus 2a minus at square dividing by t, y is equal to 1 by t into x minus 2a minus at. It looks similar to this, so let us try to check whether it is exactly in this form or not. If you take this as y minus 0, this is x minus 2a, m is 1 by t, m is 1 by t. So, we can write this as y minus 0 is equal to 1 by t into x minus 2a, you write plus minus a by 1 by t. It is in the form of this equation, is it not? M is 1 by t. If t is a parameter, 1 by t is a parameter, we can assume it as m. But in place of a, you got minus a, means this here you will get minus sign. So, it always touches the parabola which parabola? Y minus k whole square means y square is equal to 4a, but there is minus a in place of a, so minus 4a into x minus 2a. We got it. Now, we can find its length of the lattice rectum. What is the length of the lattice rectum of this parabola or this parabola? 4a. So, lattice rectum is equal to 4a. And vertex of this parabola is h comma k, no? So, here vertex is 2a comma 0. Next, what is the focus? Focus of this parabola is a comma 0, focus of this parabola is a plus h comma k. So, focus is equal to, here we have minus a, no? So, focus is equal to minus a plus h plus comma 0. What is it? A comma 0. Okay. And directrix of this parabola is x plus a is equal to 0. If it is minus 4ax, x minus a is equal to 0. If y minus k whole square is equal to minus 4a into x minus h, directrix is given by x minus h minus a is equal to 0. So here directrix is x minus h means 2a minus a is equal to 0. So x is equal to 3a is the equation of the directrix. Okay. Now I am going to explain one shortcut method for this question, because converting this equation into this form is not that easy. Getting this idea is not that easy. So I will give you a shortcut formula. Whenever the equation of a straight line is given as a quadratic in a parameter, see the given equation, the obtained tangent or obtained line L is a straight line, but it is a quadratic in T. How is it a quadratic in T? We can write the same equation as a t square plus yt minus of x minus 2a is equal to 0. This is the line L, which is a quadratic in T. As T varies, the line varies. Now this kind of line whose equation is a quadratic in a parameter is always a tangent to a fixed curve definitely. If you want the equation of the fixed curve, you directly take discriminant is equal to 0. Discriminant is denoted by delta. Delta is equal to 0. What is delta? Y square minus 4a into minus of x minus 2a means plus 4a into x minus 2a is equal to 0. We get y square is equal to minus 4a into x minus 2a. We got which one? This one. Directly you can write without conversion. Okay, all of you remember this point, note it down. Whenever the equation of a straight line is a quadratic in a parameter, quadratic equation in a parameter, that line always touches a fixed curve whose equation is given by discriminant is equal to 0. Okay. Let us proceed to next question. AB is a focal chord of y square is equal to 4ax, where capital A is 4a comma 4a, BC is a normal chord at B. Circle through ABC intersects the curve at D. Then find the coordinates of D. Take the parabola like this. AB is a focal chord. So take the focus here. AB is a focal chord. This is focus. Then BC is a normal chord at B. BC is a chord, but it is normal at B. So draw normal at B perpendicular to this curve. This is normal at B. The opposite end is C. Now if you draw a circle through ABC, it intersects the parabola at fourth point. That fourth point is D. I will draw the circle with another color. This is the circle through ABC. It intersects the parabola again at D. We have to find the coordinates of D. Very nice question. It involves many properties. Let us take points A, B, C, D as T1, T2, T3 and T4. All of them lie on the parabola now. If AB is a focal chord, what is the condition? T1, T2 is equal to minus 1. Okay. Point A is given. If this is compared with AT square to AT, what is the value of T? If you compare this point with AT1 square to AT1, T1 will be 2. T1 is 2. Since AB is a focal chord, T1, T2 is minus 1. So, what is T2? It is minus 1 by 2. Okay. Now, if the normal at B meets the curve again at C, or if the normal at T2 meets the curve again at T3, we have the formula T3 is equal to minus T2 minus 2 by T2. T2 is there, then what is T3? Minus T2 means 1 by 2 minus 2 by T2 is plus 4. So, we got T3. Next, if a circle intersects a parabola y square is equal to 4x at 4 points with parameters T1, T2, T3, T4, condition is T1 plus T2 plus T3 plus T4 is 0. We have T1, T2, T3, so you can calculate T4. T1 is 2, T2 is minus 1 by 2, T3 is 9 by 2 plus T4 is equal to 0. Then T4 is equal to minus 6. Okay. After getting T4, write the coordinates of D. D is equal to A T4 square comma 2A T4. Substituting point T4, you will get 36A comma minus 12A. Okay. Next question. Through the vertex O of a parabola y square is equal to 4x, two chords OP and OQ are drawn, and circles on OP and OQ as diameters intersect at R. If theta 1, theta 2, theta 3 are angles made by tangents at P and Q and the line OR with the axis, find the value of cot theta 3 into cot theta 1 plus cot theta 2. Let us draw the diagram. This is a parabola, O is the vertex. Parabola is y square is equal to 4x, its vertex is origin. Draw two chords OP and OQ. Okay. Now, draw circles with the chords OP and OQ as diameters. I will draw with another color. This is circle with OP as diameter. This is circle with OQ as diameter. They intersect at R. Okay. Now, what are given? The angles made by OP, angles made by the tangents at P, Q, tangents at P and Q, and the line OR with the x-axis. With the axis means x-axis, or theta 1, theta 2, theta 3. So, tangent at P makes an angle theta 1 with the axis, tangent at Q makes an angle theta 2 with the axis, OR makes angle theta 3 with the axis. That is the given information. Now, let us take P of T1 Q of T2. Then what is the slope of the tangent at P of T1? It makes an inclination theta 1. Therefore, its slope is given by tan theta 1 is equal to 1 by T1. Is it not? Then cot theta 1 is equal to T1. Similarly, inclination of the tangent at Q is theta 2. So, we will get cot theta 2 is equal to T2. Okay? Now, inclination of OQ OR is cot theta 3. Inclination of OR with axis is theta 3. Then how to get tan theta 3 or cot theta 3? We do not have the coordinates of R. Should we find equation of the circle with OP as diameter and equation of the circle with OQ as diameter and solve them? It becomes very, very long. If you observe, joining R and P, because this is a semicircle, this is diameter, no? So, this is a semicircle. What will be this angle? Pi by 2. Angle in a semicircle is pi by 2. Similarly, if we join Q and R, this angle is also pi by 2. Is it not? Therefore, Q R P are collinear. Is it not? Now, OR is perpendicular to PQ. How to get slope of OR? We have the formula for slope of the chord PQ. Slope of PQ is equal to, what is the formula for slope of the line joining T1 and T2? 2 by T1 plus T2. 2 by T1 plus T2. Therefore, slope of OR is minus of T1 plus T2 by 2. It is tan theta 3 because its inclination with the axis is theta 3. This is tan theta 3. Therefore, cot theta 3 is equal to minus 2 by T1 plus T2. T1 plus T2 is cot theta 2 plus cot theta 3. Cot theta 1 plus cot theta 2. Cross multiplying, what is the answer? Minus 2. Next question. It is a nice question. L1 and L2 are the lengths of two perpendicular focal chords of a parabola. Then find the length of the lattice rectum. We do not have anything except lengths of two perpendicular focal chords. How to find the length of the lattice rectum? Take one focal chord through the focus, its length is L1. Now draw a perpendicular chord through the focus, its length is L2. Then we have to find the length of the lattice rectum. How is it possible? Using one result which we have proved in the previous class, we can easily find. Assume that inclination of this focal chord is theta. If a focal chord of a parabola is inclined at an angle theta, length of the focal chord is 4a cosecant square theta. If you remember, we have proved it. So, I will take L1 as 4a cosecant square theta. What is this 4a? Length of the lattice rectum. Now, L2. What will be the inclination of this chord? If this angle is theta, this angle is pi by 2, no? Both are perpendicular to each other. Therefore, Replacing theta by pi by 2 plus theta, you are getting L2. L2 is equal to 4a into cosecant square pi by 2 plus theta. What is cosecant square pi by 2 plus theta? Secant square theta. Now we get length of the lattice rectum, that is 4a, by eliminating theta from the equations. From the first equation, we have cosecant square theta. We can write sin square theta is equal to 4a by L1. From the next equation, we get cos square theta is equal to 4a by L2. What is the relation between sin theta and cos theta? Sin square theta plus cos square theta is 1. So 4a by L1 plus 4a by L2 is 1. Calculate 4a from this. 4a is L1 L2 by L1 plus L2. So the answer is, in terms of L1 and L2, is L1 L2 by L1 plus L2. Okay. Now we are going to solve the last question for today. Let PQ be a focal chord of y square is equal to 4ax. PQ is a focal chord. The tangents at P and Q meet on the line say R. Tangents at P and Q meet at R, and they meet on the line y is equal to 2x plus a. But we know that tangents at the ends of a focal chord meet on the directrix, but this may or may not be the directrix. Tangents at P and Q, which are ends of the focal chord, meet at R. Okay. Then if you take P and Q as T1 and T2, what is R? R is a T1 T2 comma a into T1 plus T2. But T1 T2 is minus 1 because PQ is a focal chord. So we will get minus a comma a into T1 plus T2. It lies on y is equal to 2x plus a. Substitute. You will get a into y is equal to x plus a, no? So y is a into T1 plus T2 is equal to 2x is minus 2a plus a. What we will get? We will get T1 plus T2 is equal to minus 1, one condition. Already we have T1 T2 is equal to minus 1. Using these two, we have to find the length of the chord PQ. Let us apply distance formula. We have discussed in the previous classes. Distance between P and Q, P of T1 and Q of T2 is given by, I am taking square of the distance, PQ square is equal to a square into T1 minus T2 whole square into T1 plus T2 whole square plus 4. Okay, it is a square into T1 minus T2 whole square is what? T1 plus T2 whole square minus 4 T1 T2. You will get 1 plus 4. Again this is also 1 plus 4. So totally it is 25 a square. Therefore PQ is equal to 5a. Answer is option B. The second part of the question you try. If PQ subtends an angle theta at vertex, vertex is origin, you have to find tan theta. Very simple. Find the slopes of OP and OQ. Slope of OP will be 2 by T1, slope of OQ will be 2 by T2. Apply tan theta formula. you will get this angle. But if you apply tan theta formula, you will get plus or minus. Tan theta will be positive because you are going to apply the formula mod m1 minus m2 by 1 plus m1 m2. But you can notice that focal chord always subtends obtuse angle at the vertex. So after calculating the value of tan theta, you will get positive value because you are putting mod, then assign minus sign, then you will get the answer. So answer cannot be this or this because angle is clearly obtuse, either this or this, you calculate and check. Okay. So with this I am going to close the session for today. Okay, we are going to continue more problems on parabola in the next class. So thanks for watching, see you in the next class.